Today we are going to talk about data warehousing and data mining. For the last 10 years, companies have come up with many innovative ways of using data and information. The chapter starts with a case of Walmart. And Walmart is famous for using its information for its business and incorporating this information in the daily operations of the company. The case at the beginning of the chapter talked about how Walmart was able to use data warehouses to analyze the market basket of their consumers and find out which product sells best, in which location and during which time, during which month, and in what kind of weather condition. Right? So they are able to match the products they have in the store with a particular situation of that store and the particular weather condition. They found that during the hurricane season, they sell a lot of flashlights. That's kind of intuitive, I guess. And then they also found that they sell a lot of strawberry Pop-Tarts. And also they found that they sell a lot of beer. So during the extreme weather conditions, they can ship these products to the right place. They were able to use the information to find out what are some of the items they can use as loss leaders. They can sell these products at a loss, but at the same time, it's going to bring customers to the store and purchase products that they are going to make a huge profit on. So those are the things that Walmart is doing to analyze what customers are purchasing and how to maximize its profit. That's a great example about how data can be used to gain information for companies. Walmart uses this technology called data warehousing. Data warehousing is basically a large database. It's different from the traditional database in many different ways, actually, but probably the most obvious difference between the data warehouse and traditional database is the size. The data warehouse is obviously a warehouse of data, lots and lots of data. Companies in the last 10-15 years have collected a lot of data. They've collected a lot of data about the products, their customers, the market. However, the problem in a lot of these companies is that they are drowning in all this data, but they are starving for information. They haven't found a good way to get information out of this data. And the data warehousing is one of the solutions we have today to solve this issue. Some of the reasons for this information gap we see in a lot of companies. Well, first, information is scattered around in companies. If you look at most of the companies, you will find that information is owned by multiple functional departments. Some of the information is owned by the accounting department. Some of the information or the data is owned by the marketing, and some data owned by other functional areas. So data is scattered around throughout the whole organization. And the databases that capture these data are probably in very inconsistent format. They are probably running on very different technology, very different database management systems. Data is very fragmented, and it's very hard to put all these data together to come up with information that's useful for decision making. So that's one reason why a lot of the companies have a lot of data but have very little information. The other reason why companies are not able to convert the data into information was because a lot of the databases they have in the companies are designed for daily transaction processing. It's not really designed for decision making. As you will see in this chapter, the database you need for decision making is actually very different from the databases you need for transactional processing. For example, for transactional processing, the information you need is the most up-to-date information. When you process a credit card transaction, you want to know the current price of the product. You are not interested in yesterday's price of the product. You are interested in the current price of the product, right? But in the decision support system, the data you need would be historical data because you want to find a pattern. You want to find a trend. So that's why a lot of the databases in companies are not really designed for decision support. They are mainly designed for transactional support. Data warehouse is one of the technologies that can help us bridge the information gap. It's able to bridge this gap by integrating data from many different sources, many different databases, and it's designed for decision making. It has historical data to help us with decision making, to detect the trends and patterns. This topic is getting more and more important because more and more companies are using data warehousing technology. Right? And also the other reason is because we have a number of new technologies that are helping us capturing more data from the customers, from products, or the market. For example, the web-based systems. A lot of the companies, they sell products over the web. We are able to capture a lot of online activities of the consumers. For example, the click streams, which page the user viewed during the transaction, transaction, things like that. So this information can also be analyzed for business uses. And also we have new technologies like RFID, which can be put on pretty much anything these days. You can monitor the movement of products, and also like the GPS system that allows us to track the movement of people or mobile properties. So today we have a lot of capabilities to capture lots of data. So data warehousing is becoming a very important technology for us to analyze these data to come up with information. Some of the topics we are going to cover in this chapter. First, some definition of the terms, some of the reasons for data warehousing, some of the advantages of data warehousing, and we'll talk about the difference between data warehouses and the traditional databases. We'll talk about the design of a data warehouse, how it differs from the design of the traditional database. We'll talk about the size of the database, and we'll talk about a concept called the data mart, which is data warehouse with limited scope, but it's often what the end users end up using to analyze data. What is a data warehouse? Well, as we talked about earlier, data warehouse is basically a large repository for data. It's a subject-oriented, integrated, time-variant, non-updatable collection of data used in support of management decision-making process. Let's take a look at these 4 characteristics. The first one, subject-oriented. Well, it basically means that the data warehouses are often organized in terms of the subject. For example, the data warehouse may be organized around the subject of customers, or it may be organized around the subject of patients, right, or students, or products. So usually the data warehouses are organized around these high-level data elements the company is interested in. So that's what we mean by subject-oriented. And the second characteristic is integrated. That means that the data in the data warehouse come from many different operational systems. It can even come from external systems, such as the database from the Census Bureau, the database from the Department of Motor Vehicle, the stock market. It gets data from multiple sources and then integrate these data so that they can be analyzed together. So that means that all the data in the data warehouse should have consistent naming conventions, have consistent format, like consistent encoding structures, so that they can be analyzed together. The third characteristic is it's time variant, which means in the data warehouse, not only we have some of the latest information about the business, we also have historical information. We have snapshots of the databases of the company in the data warehouse. And the reason for that is because we want to look at the historical data in order to identify the trends and the patterns in the business. And then the last characteristic is non-updatable. That basically means the data warehouse is often read-only to the users, not allowed to change the data in the data warehouse. They are only allowed to read the data and analyze the data, query the database. Now that's important because we want to provide the users with historical data that's not designed for update. The data is periodically refreshed and updated, by the information systems professionals to put new data into the data warehouse. Another related concept to data warehouse is something called the data mart. It's basically a small data warehouse. It's a data warehouse with limited scope. In most companies, what happens is the users do not interact with the actual data warehouse directly because it's simply too large to be queried by the user. The users are often interacting directly with the data mart, which is a smaller version of the actual data warehouse. There is some information about the benefits of data warehouse in the chapter. It mentioned that the return on investment for the data warehouse projects is about 321%, which is very high. Compared to other investments in technology. And then the payback period for data warehouse projects is about 2.73 years, which is also pretty short. Even though data warehouse projects can cost millions and millions of dollars, the payback is actually pretty significant for these projects. What's making data warehousing possible these days? The concept of getting information out of data is not really a new concept, but we haven't been able to do this very successfully until now. why now? Why is data warehousing all of a sudden possible? Well, a number of reasons. First of all, the improvement in the database technologies, especially the relational database management systems. And as you will see, data warehouses are usually designed using the relational database technology. And so today we have very robust database management systems that allow us to query database in a very flexible way. And then the second reason is advances in computer hardware, including the mass storage and the parallel architectures. Data warehouses have terabytes and terabytes of data. In order to process this data in a timely fashion, we need to do what's called parallel processing sometimes. And also in order to store so much data, we need to have relatively inexpensive mass storage devices. And the third reason is the emergence of end-user computing with powerful interfaces and tools. In order to get the information out of the data, we need to have data mining tools to mine the data. And these data mining tools can be the statistical tools. They can be the artificial intelligence tools, which will facilitate machine learning. Those are pretty sophisticated software. Today we have the capabilities of developing these sophisticated software. And also when we get the information out of the data, the information needs to be presented in a way so that the users can understand it, right? And so we have very powerful data visualization tools that allow us to look at data in many different ways to understand it. That's also making data warehousing possible, right? And also the advances in middleware enabling heterogeneous database connectivities. That's also making data warehousing possible because data warehouses get the data from multiple databases. Sometimes they are probably using very different technologies. To enable these different databases using different technologies to be integrated, it really requires to have these powerful middlewares that can convert data from one format to another format of technology. But the most important thing that's leading to the popularity of data warehouse these days is really the recognition of the differences between operational and information systems in organizations. Companies are starting to realize, well, there is a difference between the operational systems, which are the systems we use to process daily transactions, and the informational systems, which are the systems to support decision making. The operational systems, the primary purpose is really to run the business on a current basis. What it means is we use the most current, most up-to-date information to run the business, to process transactions. But for informational systems, the main purpose is really to support managerial decision making. And that means to look at the history of the business and try to come up with strategies, come up with trends and patterns. And the type of data the operational system is interested in is usually the current representation of the state of the business. But for informational system, we are more interested in historical data, the historical snapshots of the business. The primary users of operational systems are clerks, salespeople, administrators. The informational systems are usually used by business managers, business analysts, and the customers. There are many differences between the operational systems and informational systems. Once the businesses have realized the differences between these two types of systems, they realize, well, there is really a need for them to come up with this new technology or new system for supporting decision making. It's very important to separate these systems. Well, you need to have good performance for both systems. You don't want the informational systems to slow down the operational system. And you don't want the operational systems to slow down the informational systems either, right? So it's important to separate these two different types of systems. The operational data are often fragmented and inconsistent with each other. That will be a problem. There are a number of issues we have to deal with before we can create an integrated data warehouse. The first issue is the inconsistent key structures in the operational databases. For example, if you have multiple database tables related to customer throughout the whole organization, maybe you have a customer table in accounting information systems, and then you have another customer table in the marketing information systems. And they may have very different key structures. For example, the primary key for the customer table in the marketing database may be customer name. And in an accounting database, it may be the customer's social security number. And then in another customer table, in another database, the key may be the customer ID. They may have very different key structures, and that makes it very hard for us to consolidate these data into one data warehouse. The other problem is the synonyms. Synonyms basically means the same thing that's called different names. Right? For example, customer ID or customer code, customer social security number, they may all mean the same thing, but in different database tables. And then sometimes we have free-form data instead of the structured fields in a database table. For example, in one database table, we may have the name as first name followed by the last name. And then in another table, we may have name as last name, comma, then the first name. And then in another database table, we may have the first name and the last name in separate fields. And also we may have inconsistent data values because the data may be updated by different people during different time, right? In one table, we have the customer's phone number, and then in another table, we have a different phone number because it was updated by somebody else during a different time. And sometimes we also have missing data. As you can see from this example, we have student information in multiple places throughout the whole organization. We have student data in the student information system, and we have student employee table, which is probably in the personnel database of the university. And then we have the student health information in the university's health record. All of these three tables deal with the student data. However, they have very different key structures. The first table uses student number as the primary key. The second table uses student ID as the primary key. Even though the student number and student ID are the same thing, they are called differently in different tables. In the student health table, the student name is used as the primary key. And then there is some missing data, there is some inconsistent data in these tables. Those are some of the issues we run into when we try to integrate data from different sources into a data warehouse.